Okay, stats kids. I'm gonna fill in with you your yellow sheet stuff that you will need for chapter 8. If you do not have a yellow sheet, my sub has extra ones for you. We're gonna fill in like an entire front side of a yellow sheet, like 6 slots or 7 slots. So you may need to get a new one from her. I said that some of you might have some, but you might just want to get a new one anyway. But you should grab that from her, and then you should also have a chapter 8 review. So we're going to go through and fill out the yellow sheet, and then I'm going to give you just a couple problems on the review to do for tomorrow. And we'll go with that. So what I'm going to do is I'm going to start off so we've got 3 sections to this chapter. The first one is proportions, which are listed off to the side over here. Then we have means, then we have standard deviations, okay? And I kind of tried to get some of that information written out to begin with, just to make things go faster. So if you want to pause and write all this information down, at least for proportions, these 3 rows, do that really quick, and then we'll go through and fill in example solution stuff, okay? So pause and go. All right, I'm going to zoom in now on the important information. I have all your variables listed out. This is everything that you will need for a proportion, whether you're doing critical value method, p-value method, confidence interval method. All of those will involve probably the majority of these variables. So let's just fill those in. So P is going to be your population proportion, P-R-O-P. So that's like whatever it is you're talking about, the certain percentage of whatever, okay? Q is 1 minus P. Okay, then you have P hat, which is your sample proportion. So whatever sample that you're given, the percentage or the decimal number percentage of whatever it is that you're talking about. Q hat is 1 minus Q. Now, be careful when you're using Q and Q hat or P and P hat, because when you're doing the critical value method and p-value method, you're going to use this formula. And notice that the stuff underneath of the square root is P and Q, versus when you're doing the confidence interval formula and you're still doing a square root, but you're doing P hat, Q hat. So be very careful which method you're doing and which P and Q you are using, okay? N is the number in your sample. We probably don't even need to write that down because you guys are good at that, but we will. Z is your critical value. And you will use the critical value regardless of whichever, I guess you'll use it in all of these methods. You'll use it in every single method. So this is the number that you look up on the chart. And I'm going to say always Z chart. For proportions, you will always use the Z chart. And that's that positive negative chart, and the little box down in the corner, that's where you'll find those Z values, okay? All right, so then we have formulas. We have, this is your, they call this the test statistic, and they name it Z. So the test statistic, you will use this same formula to calculate the test statistic, whether you're doing critical value method or p-value method. It doesn't really matter. You'll just do that exactly the same. And then confidence interval, you will need to have p hat minus the error, p hat plus the error, and then the population P will live in the middle of those two. Your error is calculated by doing this stuff, okay? And again, all those variables we've listed up above. So that's kind of how that works, okay? All right, this is my example that I have given. In a sample of 100, so I'm going to start writing stuff down. I'm going to say N equals 100. I'm going to list it off to the side over here. 32 of them drink coffee. Well, that doesn't give me anything, but I do know from that information that P hat is 32 over 100, which is, I made that really nice for you, 0.32, 32% or 0.32, okay? Then I can calculate what Q hat is. I will eventually need that at some point. That is going to be 0.68. And then let's continue reading. So we are testing the claim that less than 35%. Well, 35% is what we're comparing to, so that's going to be the P, so 0.35, which means Q, just Q, is going to be 0.65. So just slightly different numbers. And then they tell me to use a significance level of 0.05 to do that. Okay, so because the test statistic Z is used for both of these methods right here, I'm going to calculate the test statistic down over here. And I'm going to need to go grab a calculator, so hold on. Let's fill it out though. Z equals, we also need to figure out what our critical value Z is, not the Z that we're calculating for test statistic, but the critical value Z is. We'll do that with the chart here in a second, which I don't know Yeah. Okay. All right. So p hat is 0.32. I'm filling this formula in right here. P hat is 0.32 minus p, which is 0.35, all over the square root of pq. P is 0.35. Q is 0.65 all over n, and n is 100. Okay, so I calculate that value. I'm gonna have to go get a calculator. Sorry, this might take a minute. If you want to fast forward, go for it. But I'm gonna go grab a calculator. Maybe. Nope, I need it. Okay. Okay. Okay, and I got 0.64, I believe. It would not be about negative 0.64. It would not be a bad idea for you to try practice calculating that. Maybe I did it wrong. I don't know. You might have to compare with each other to make sure that that's the right number, but that's what we're going to go with. So negative 0.64, that is the z-score that we are comparing stuff to. Okay, now from here, the only thing we do is just two different bell curves depending on which one we're looking at, okay? All right, for critical value method, these are going to be on like the z-scale. So these are all z's. This is the p-value scale. So we're going 0 to 100% here. Here's 0 as a z lives in the middle, okay? So that's the only difference. And we are using a 5% significance level, and we're doing less than, okay? So let's do this maybe. H naught, H1. We are saying that p is equal to 0.35 and p is less than 0.35. That's what our stuff will be, and we're going to do just one tail then. And we still have an imaginary tail over here. So 5% is my significance level, this guy right here. That means all 5% is going here, and I have an imaginary 5%. And that is going to be 90% in the middle, okay? 90% in the middle, I gotta think. 90%, I believe, is 1.645. So we have negative 1.645 and a positive 1.645, I believe. Okay, versus down here, what we're going to do is, shoot, I'm going to have to look up some stuff. Negative 0.64 is what we're going to look up, and we are going to find, no, I guess that's not true. Well, okay. When we're looking at conclusions here, negative 0.64 is going to live right here. So that is in the do not reject range. Do not reject, which means our claim is false because our claim was going with the bottom one. So even though 32% drink coffee, that is not significantly less than 35% to say that it's less than. So we're going to say that 32% is close enough to 35% to say that they're equal. Okay, so claim is false. All right, now for p-value, we have 0. Since we're doing 5%, this would be the 5% mark. Our imaginary 5% would be 95 over here. So that's how that's going to work out. And then we have to look up negative 0.64 on our chart and figure out what the p value is. I got to go get a chart. I'm so unprepared. Give me just a minute. Fast forward to the part where I actually have this. Okay, so we will have to look this up on the negative side since we're doing negative 0.64. And I found 26. I can't see. 0.2611. 0.2611 or 26.11%. And if we look at our scale, 26.11% is going to live like, I don't know, greater than 5%. And so that again is a do not reject. Same result. As it should be, same result. Okay? All right, next we're gonna do this same thing, but we're doing the confidence interval methods. We're doing this guy instead now. Okay? All right, p hat was, we got to calculate the error first. Let's do that. Error is z. Okay? Since we're still doing this alpha level of 0.05, we're going to use this z-score, which is 1.645, and then we're going to finish the rest of our formula here. Let me check. 1.645, and then we've got the square root of p hat, which is 0.32. Q hat is 0.68. And n is 100. Okay, so there's a difference between these two. This one's P and Q. This one's P hat, Q hat. Okay, so be careful of that. All right, I gotta do some. Oh, shoot. Hold on. 0.35 times 0.65 divided by 100. Shoot. I think this last number was supposed to be 0.63, I think. So our p-value will be off just a little bit. It will actually be, I don't know, not 26.11. I think I typed something in wrong. 0.63, 26.43. Okay. It'll actually round to 43 instead of, yeah. So just a little bit of a change, but it still doesn't change our result. It's same. Okay, let me do some actual calculations here. All right, we've got 0.32 times 0.68 divided by 100, and the square root of that, and that times 1.645. Okay, so I got, for an error, I got 0.077, which is 7.7%. So however you want to write this out, we can write it out as percentages, I guess, if we want to. P will need to live in between. I add and subtract this from P hat, which was 32%. So I'm going to take 0.32, and I'm going to subtract 0.077. And on the one side, I get 24.3%, and over here, I get 39.7%. And then what we're doing for the confidence interval method, this is kind of the easy part. With my hypothesis, 35%, looking up here, 35% was what my hypothesis was. And what we're doing is we're looking to see, does 35% live in here? And if it does, then that means we're going to circle this top part. And we're going to cross off the bottom one. So same result as what we got before. Do not reject, claim as false, because 35% does in fact fit in there. Okay. All right, let's go on down to means. We got means to do. Okay. We only did critical value method for mean. We did not do the p-value method. And then we have confidence interval method. Okay. We've got all of our stuff here. If you need to write this down, go for it. So pause. I'm going to start with the variables. So mu is the population mean. X bar is the sample mean. And then depending on what we're given, if we're given S or sigma, both of those are going to stand for standard deviation. Those things will help determine whether we use the T or the Z chart. Okay, if it's S, we use T. If it's sigma, we use Z. But another thing that determines that is if we only know S, we can still use Z, but N has to be greater than 30. Here, N is less than 30. So if we have N less than 30 and we only know S, which is usually what happens, we're going to use the T chart. Okay, so put all those things down, and that will help kind of identify the same rules as before, T or Z. N here is the number in the sample, and then this is the number from chart. There we go. Okay. All right, here is our formula. And then we've got our example over here. Oh, we've got formula down here for error. Okay, let's go over here. And I'm going to list stuff that we have. The average ACT score for 20 juniors, that means N is 20, was, and we're talking about the sample average, so 22.4 is the sample. That's what they got, with a standard deviation of 2.1. That's the sample's standard deviation, so it's S. Now, I know that at this point, I know that we're going to use the T chart because N is less than 30 and we only know the sample standard deviation. Those two things tell me T, okay? So I'm going to write that down. And we are testing the claim that the average ACT score is, I'm going to circle the words, is or is equal to 20, okay? So we are going with our mu being 20, and I'm going to list H naught and H1 over here. We're going to say mu equals 20, and mu in this case is not equal to 20. And this time, my claim is going to go at the top because we're claiming that it is 20, okay? And then we have to find T here in just a minute, but I'm going to list here I'm going to have a bell curve, okay? And we are doing equal to and not equal to, which means we have two tails. Okay. So, and the difference here is if we have a significance level of 5 or 5%, just like we did up here, but this one has two tails, so we have to separate them in half. 2.5% goes there and 2.5% goes there, which means we have 95% in the middle, okay? So, to do the critical value method, these are going to be all my Z-scores. 0, again, lives in the middle. I'm going to go to the T chart, and I'm going to look up, maybe something else I need to list. Degrees of freedom will be 19 degrees of freedom. And I want 95%. 95% at 19 degrees of freedom, I think is like 2.093, I think, if I'm looking at the right column. Yep, 2.093. So I've got negative 2.093 and positive 2.093. And then we're going to calculate, so 2.093. And then we're going to calculate what T is using the formula. So 22.4 minus 20 all over S, which is 2.1 over the square root of N. Oh, heavens. Okay. Let's do this. I'm trying to use my phone as a calculator because I am not prepared. And so please excuse me if I get some of these numbers wrong. I get something like, and mine is not quite accurate because I did some partial conclusions, but I got 5.11, which is like all the way out here in reject land. So we're going to say that the ACT scores are not equal to 20. So this is a reject H naught, and claim is false. We're not doing very good on claims here tonight, or today. So, which I guess makes sense. 22.4 is not very close to a 20. I mean, like to say that those are the same thing. So I would believe that. All right, now let's do a critical value method instead. So we're going to go to this. We have to calculate the error. So we have T. Again, we're going to use that same T, 2 error, 2.093 times s is 2.1 over the square root of n, which is 20. Okay, so I'm going to calculate all that stuff and see what we get. Okay, 2.093 times 2. I got 0.98 for an error. And again, we're adding and subtracting that to x bar, which is 22.4. So if I do that, I get 21.42, let's say. If I add it, I get 23.38. Okay, and we're looking to see if our number, which was 20, that's what we're testing against, if he lives in there. And he does not, because this range is entirely outside, like 20 would live over there. So again, that's going to be a reject that's not equal to, because he doesn't live in there. So reject H, not claim false. Same thing again, okay? All right, last one, standard deviation. Holy cow. We've got this information. Pause if you need to. I'm going to list variables and all this good stuff. So this one is the population, standard deviation. Then we have the sample, standard deviation. Then we have the number in the sample. Then we have your number from chart, and this is only using the chi-squared chart, that weird one that has two numbers from. Okay, this is your test statistic. Okay, and then this is your critical value method, where you have those two things that you calculate. Okay, so two different ways. I'm going to list my bell curve over here, my H naught and H1, and we'll be good to go. Standard deviation for heights of 53 freshmen, I'm going to say N is 53, was 4.2. That's according to my sample, it's 4.2. We are testing the claim that the standard deviation is greater than 4. So we're testing against 4, but we're testing to see if the standard deviation is greater than 4. That's the claim. Okay, and we're going to say standard, not mu. Why am I using that variable? I don't know. Sigma, and sigma equals 4. Okay, so that's what we're testing against. Again, our significance level is 0.05. I'm going to look up the two numbers, the chi-squared right and the chi-squared left. And I guess we can say degrees of freedom has to be 52. I don't think we have a 52 on our chart, though. I think maybe we just have a 50. Let me look. 50. Yep, so we'll have to go down to 50 degrees of freedom, and we're doing I gotta zoom out. 50 degrees of freedom, and we don't know what our, if we are doing greater than 4, that means we have one tail, and all 5% is going to go in that tail, and we have an imaginary 5%, so 90%, which I think are our middle two columns. 90%. 90%, 50 degrees of freedom, 37.689. That is the left one. And I need a secretary to help me do this. 63.167. There we go. Okay, there's my two numbers. All right, so if we're doing critical value method, those are actually the legit numbers that go here. And 63.167. Those are my two numbers that go there, and we have to just calculate this information. So I'm going to do that here. Chi squared is n minus 1. I'm going to do some of this in my head, so that's 52. Standard deviation is 4.2 squared over 4 squared. Okay, that's that. And I got chi squared is... Okay, again, you don't square root. You don't do any of that square rooty stuff. You leave it as chi squared because that's what it is. Okay, all right. I got 57.33. Okay, 57.33 is in here in comparison to those two numbers. That's in do not reject land. We're just really bad at claims here. I think we've rejected the claim every single time. Do not reject H not, which means claim is false again. Okay, let's see if that's our same conclusion when we do all this good stuff. So my sigma is going to live in between those two things. I've got the square root, n minus 1 is 52, s squared is 4.2 squared, and we're doing over 37.689 because we crisscross these. No, wrong. I said to crisscross and then I didn't. 63.167. And then on this side, 52, 4.2 squared over, there we go, 37.689. Okay, sigma lives between those things. Let's see what I get. I got 3.81, and then I got 4.93, okay? And what we're comparing is this number, which is 4, and 4 does in fact live in there. So we're not going to say that it's greater than, we're going to say that it's equal to. Same result again. Do not reject, claim false, okay? Holy cow, that was a lot of information. Oh, man. But that should do it for your yellow sheet. What I would love for you to do is the front side of your chapter review just has some like hypothetical questions, I think. Nope, this one, number 3, has it all the way through, I think. So that one is a full test. If you want to go ahead, why don't you try to do 1 through 6 if you can? And then we will do some more of these tomorrow, okay? And I'll give you some more instructions on the back stuff tomorrow. But try to get through 1 through 6 maybe, and we'll see how that goes, okay?